So the main event tonight is a presentation by my colleague, my neighbour on the Harwell campus, Dr. Mark Bashham. I've collaborated with Mark on a couple of projects over the previous 6 years. The most recent one was running some code developed by Mark's group on a storage and compute cluster made of Raspberry Pi single board computers. Now, it's just been the 10th anniversary of Raspberry Pi, and hence this is a very good time for Mark to tell us how he uses Raspberry Pi, other technologies such as Lego, at public engagement events. So with that, I'd like to say that if you have any questions during the presentation, please use the Q&A tool at the bottom of your Zoom window to submit a question. We'll be monitoring the Q&A area for questions. We won't be looking at chat. And at the end, we will go through as many of those questions as we can. So with that, it's over to you, Mark.
Brilliant. Thanks very much, Ian. So let me just share my screen quickly. And hopefully we'll all be good. Can you all see that okay? Yep, perfect. Brilliant. So yeah, thank you, Ian, for the introduction. So yes, I'm going to talk a little bit about Raspberry Pis and other technology to engage the public in science. And so I think as we kick off, the first thing really is, who am I? So my name's Mark. As Ian said, I work at up on the Harwell campus on the sort of the STFC, so the Science and Technologies Facilities Council run institutes up there. And specifically, I work at two places. I work at the Rosalind Franklin Institute, which is where I currently work most of my time, and also at Diamond Light Source. So a few things on here. I love playing with Lego. That's a really important part of this, and it'll be a big part of the talk later as well. I ride a motorbike. I'm really particularly happy at the moment because it's an electric motorbike. It's very, very cool. So I can talk about that for another hour if you want me to have do anything, any other engagement stuff with you guys. But I'm active on Twitter. I'm Celtic, so I'm Cornish originally, although most of my accent has been eroded by 20 years of living in Reading. And I love nature as well. So I think it's just a round of what I do, and specifically in terms of technology. So I'm now the lead of the artificial intelligence and informatics theme at the Rosalind Franklin Institute, where I, with my team, write software to analyze the data that's collected, the scientific data that's collected. So these are the two places that I work. So if you've ever driven down the A34 that you can kind of see in the background of the picture on the right, you'll probably have seen the Harwell campus. The big donut is Diamond, so it's the UK's national synchrotron facility. So it's a particle accelerator, and we use that to accelerate electrons to very near the speed of light, and then bend them around corners, which produces amazingly bright X-rays. And we use those X-rays to do all kinds of different science. And sort of analysing the data that comes off that was part of my role at Diamond for probably about the last 10, 12, close to 15 years. The Rosalind Franklin Institute is a much newer building. As you can see, it looks very, very shiny. So it's basically, it was completed about this time last year. So we've been in the building for probably 9-10 months now, and we're just getting a whole load of new instrumentation set up there. And what the Rosalind Franklin Institute is all about is using, so it's funded by the physical sciences, and it's all about bringing the technology from the physical sciences to bear on life science problems. So a lot of it's about electron microscopes, and also we're collecting data. So basically making use of all of that data in the best possible way and trying to apply the new techniques and the new technologies from computing, such as artificial intelligence, machine learning, to that data to get the most out of it. So that's a little bit about me, but I guess the key thing we wanted to talk about was engaging the public in science. And this is something that I've been doing for quite a long time now. It was something that I really got involved with when I started at Diamond. And as I say, for me, it's a very, very important part of my job. And the methods that you can use to do that are kind of interesting. So One of the great things about working on the RAL campus is there's loads of really inspiring engineering. So, you know, if you ever have the opportunity to go to Diamond and have a tour, they're doing virtual tours at the moment. Hopefully they'll do in-person tours again at some point. You get to go inside the machine and you can look at, you know, 580 odd meters of amazing technology in a big circle. It's, you know, it's phenomenal, the level of technology. We've got large compute rooms and systems. You've got, you know, networking and you know, very, very high levels of technology in sort of rack systems and this kind of thing for computing. We've also got sort of phenomenal levels of engineering and technology, just even in bits of kit that sit on lab desktops. So when people come to visit places like Diamond and places like the Franklin, it's really easy to show them all the really shiny kit, and it's phenomenally inspiring. And I love this, especially because when I do that, it reminds me of why it's really nice to work in these places, because you see other people go, wow, this is cool. And you kind of think, yes, okay, yeah, it's really fun working here and I enjoy this. But that's great. But, you know, we've had the pandemic for the last couple of years. We haven't been able to have visitors, and people can't always come to Oxfordshire. So sometimes we have to go out and about on the road. And when we do that, often it becomes more tricky. We can't bring the synchrotron with us. So in this case, this was actually at the National Eisteddfod in Wales. I can't remember which one this is. We went there about 3 or 4 years in a row to various places around Wales, and but you can see that it's very, very different, right? We've got specific exhibits and things that we've brought with us, and some of these, there's actually a lot of technology still on display here. You can see there's a sort of a microscope there. We've got a touch screen that's showing videos and interactive 3D models. And the bit that I personally like, my favorite thing is the screen on the right, which a little bit closer up is a really lovely 3D screen that we got. So it's quite a big screen. It uses the polarized glasses and the polarized screen across the front. So you pop your polarizing glasses on, just like the ones you use in the cinema if you go to see a 3D film, and you get these amazing 3D effects. And it was a really nice telly, so it's got a really good quality screen on it. And this was quite a while ago, but you can actually see there is the models that you're seeing here look fuzzy, and that's because with a normal camera we're seeing all of the data for both eyes. But this was a brilliant piece of tech, and it was great because we could show the protein structures that you can see kind of at the top and left there, but we could also show things like tomography data. And on the right, you can see a good old, I think it's a Raspberry Pi version A. So it's the first one that just sort of sitting there, which we'd scanned, and then we're able to visualize in 3D. And these are great because, you know, people come along, they put the glasses on, the stuff looks amazing, they get to play with all the things. And, you know, these exhibits are great, and they're really nice for inspiring people. But one of the problems that I sort of noticed as we were doing this was, you know, this classic quote from Arthur C. Clarke was, you know, any sufficiently advanced technology is indistinguishable from magic. And that's what people see when they come to visit the synchrotron, or they come to visit and they look at the equipment, or they come to visit and they, you know, or we show them these amazing pieces of technology, the stuff that they don't necessarily interact with all the time. That 3D screen was from before they became kind of a bit more mainstream and people possibly had the opportunity to interact with them more. Then it becomes really interesting, and they can become inspired by it, but often they can't equate it to something that they understand, and it just becomes this thing that's magic. And it's just, yeah, this is what those, you know, the other people do, this is what the scientists do, this is what the engineers do. It's not something that I do, it's something that somebody else does. And that unfortunately breaks some of the engagement, the sort of the things that we really want to do with the engagement, because people feel that it's no longer something that they could do or they could engage with. And so one of the things that I really wanted to try and do was to engage people by more interaction, and trying to start thinking about things that they could make use of that potentially they've got more of an idea about. And actually, this started in a strange place. So there's an amazing competition that you can take part in called I'm a Scientist, Get Me Out of Here. And there's also another one that was started a few years later called I'm an Engineer, Get Me Out of Here. And it's incredibly loosely based on the premise of I'm a Celebrity, Get Me Out of Here, in that you have it's a completely online virtual event. You have a room of 5 people. they each get to answer questions from a whole bunch of school kids. Usually there's about 3 or 4 classes worth of school children that ask you questions, and there's some live events, but there's just a general sort of Q&A session as well. And over the course of a 2-week period, in the first week, you just answer questions and you chat about stuff. And in the second week, slowly but surely, each of the people in the rooms get eliminated until there's only one person left. And that's chosen by the school children. And the reason for doing this is, one, you get some really cool public engagement stuff out of it because you get to talk to loads of people. But there's also a £500 prize that you can spend on public engagement if you win. And it's one of the things that you put on your profile. So your profile, when you're in the competition, has a few bits and pieces in it. But the key thing about it is it says what you're going to do with this £500 prize. And so I was looking at the equipment we have at the Beamlines, and there's loads of cool kit and loads of bits and pieces of detectors, but there's a few sort of standard things. We've got a sample stage that rotates, and all of these detectors are just really light sensors. Okay, they detect X-ray light, but they're just sort of light sensors. And so I thought, what's something that is, that the public can engage with and understand potentially, that's a little bit less scary than all this tech. And I thought, oh, I could go to a good favorite of mine, which is glorious Lego. And when I started investigating this, I found that the Lego Mindstorms education set was roughly £500. And it's the sort of thing that a lot of schools have got. So if you haven't seen these before, they're like a little brick module in the middle that's got some basic controls. You can program it using a kind of a modified version of LabVIEW. And it's got a bunch of motors and sensors, and it's designed for building robots and all sorts of things like this. And I thought, well, there must be a nice way of doing this. So I put my proposal together, and that was my thing. And I participated in this. And the first week was great. We had loads and loads of conversation. And then at the weekend, at the end of the first week, I realized that I needed to start understanding the standard model of particles. And the reason for this was truly annoying, because in my group, it was all about scientists who worked on big scientific instruments. And so there was a couple of, so I was working from a synchrotron and data analysis. There was an accelerator scientist there. There were also a couple of neutrino scientists. And so neutrinos very, very quickly became my least favorite particle in the standard model. They're just down here at the bottom. Very, very annoying, because on the weekend in the middle of the I'm a Scientist event, it was in 2011, and this was when they observed that neutrinos appeared to travel faster than the speed of light. And neutrinos were suddenly on every single media outlet. They were on the news. They were absolutely everywhere because of this. And at the time, it was done very, very well, in that they said, we were pretty sure this isn't correct. We don't know where the mistake is. However, it did mean that I did come third in that competition, behind the 2 neutrino scientists. So I still haven't given neutrinos for making me come third and not getting the £500 prize. So I couldn't go ahead and purchase the Lego to build this Beamline with. However, the plus point was, as I was regaling the communications team at Diamond with this tale of woe, they said, oh, it's quite a nice idea, we'll buy you one anyway. And so they bought me one of these Beamlines, and this is the first version that I created. This is an event we went to, and I'm really sad because I don't actually have a better picture than this of this. And in fact, this is actually the slightly updated version, because the very, very first version didn't have the plotter that you can see on the left. It just had the Beamline itself. I'll show you how it works in a second. But actually, one of the things that was really interesting was how the development of that came, because when we just had the thing itself, the line that you can see plotted on that piece of cardboard on the left, that was just shown on a screen. And it wasn't particularly interactive. And one of my colleagues said, oh, if you could make a plotter for it, that would be really cool. And then we thought, well, maybe we could use these postcards that we get printed anyway. We could put the information on there, and it's something for people to take away. And that suddenly made it a lot more engaging. A lot more people sort of engaged with it a lot better. And so after version 1, version 1 wasn't particularly great. I'm going to admit that it was definitely a first version of things. We created version 2, or I created version 2, and version 2 was a little bit easier to run, but we've got a demo of it actually working here. And you can see it's a laser pen. It's shining through a diffraction grating, which is creating a series of spots. You'll be able to see them a bit better in a second. And the arm sweeps around as the light sensor, so it's a standard Lego light sensor, goes through the different spots of light, then the arm on the plotter goes up, and as it drops down, it goes into the dark sections in between, it drops down. So I'm just going to try and very badly here, sorry, show you as you shine the light through, you can see the spots that have been created by the diffraction grating. And this is actually how quite a lot of the beamlines at Diamond work, is they use the sample as a diffraction grating effectively and shine X-rays through it and then collect it with a slightly more sophisticated sensor. But you can essentially see how this process works. It's relatively quick. You pop your new card in, you get that going. And once it's in, you get the punter usually to press the button and shine the light. And all of a sudden you get these glorious plots, and you can see the individual spots going through as the arm rotates round. And you get these lovely patterns, and it's something that they can take away with them. And the great thing about it is that because it's Lego, people kind of feel that it intrinsically can't be that difficult. It's got to be reasonably nice. And so there's the beamline that was inspired it on the back. And so obviously we go forward and we create a new version of this. This is the version 3, attempting to be even easier. In fact, actually, this one was a bit of a strange one, because this was using the new EV3 system. And actually, I could never get this to run quite as well as the older system. The way the control system works just didn't quite give you as good a result. You see it's a lot slower here. But effectively, yes, these worked really, really well. We've taken them to events all around the country. They've been used a lot, and it's a really nice way of engaging the public, because they do get to see, you know, stuff that they're used to, especially schools. A lot of schools have got these educational Mindstorm sets, so they're used to building sort of robots with them, but they see, well, okay, you, instead of driving the tank tread here to drive my robot, I'm using it to drive the plotter across. I'm just using these cogs to move the arm around. I'm using the light sensor to detect the light that we're scanning. And so it's the same sort of stuff they're used to, but just in a different way, and we're collecting scientific data with it. So the Lego Beamline, as I say, was a great success, and it kind of allowed us to do loads of really interesting things. But it was very much targeted at the Beamline, and you know, I'm a software developer, so I write software. I work with a lot of the groups who run the compute systems, and so you know, it's always one of those things: is there a better way that we can sort of represent these compute systems? So I think this is a picture of Jasmine up at the STFC campus. It's a kind of very cool compute system, and it was like, well, is there a nice way we could do this with kind of commodity hardware? And so I immediately thought, well, you know, when I was young, what was the sort of commodity hardware that I would recognize and understand? Because, you know, rack systems look very, very different to the computers that I'm aware of. So I thought, yeah, we could maybe put together a cluster of maybe something like an ORIC, you know, something that everybody's aware of and everybody knows. And I thought, oh, maybe that's a little bit too niche and possibly shows my age. So maybe a BBC Basic would be a better option for building this cluster. And then realistically, realism kicked in. I realized it was only sort of 2011, 12, and the Raspberry Pi had just come out. And all of a sudden it was like, oh, hang on, you know, here's this, you know, single chip on a board system that's, you know, that's very, very cost effective. I think it was about 35, 40 pounds when they came out. It was pitched to be purchased by anyone. You know, a lot of the stuff was very much designed to be the BBC Basic of the age, in terms of giving people the ability to have a computer that they could just use and that they could play with. And so, of course, this then was a really good target. And in fact, it was one of my colleagues at Diamond who created the sort of the Raspberry Pi MPI cluster, Dave Bond. And I'm really sad because I do not have a photo of it. It was absolutely beautiful. He'd put it in a cigar box. So it was in this glorious wooden cigar box. It looked absolutely beautiful. I was pretty sure it was terrible for cooling, but it looked incredible. So this is just one that I found off somebody's blog, but it's very, very similar in that it was 4 Raspberry Pi stuck together. There was one sort of master node. And what it did was it solved, I think he got it to do an ASCII art Mandelbrot set. And it spread the task over the 4 different Pis, calculated them, and then brought them all together and displayed that. And it was really nice because it allowed, you know, it was something that people were kind of aware of. People had often seen the Raspberry Pi. There was lots of media about, so people were aware of it, and it was in schools. And so you could kind of see how you can, okay, well, I'm just connecting more of these together. I'm splitting up my task. I understand how that works. And so it really did enable people, because of the fact that it wasn't this rack mounted system, see what was going on and understand that process. So that leads us on to Wolfie, which was the project that I worked on with Ian on. And I was doing the software side of this with my team, but the actual Raspberry Pi system here is beautiful. So this was I think it was a 12 Raspberry Pi system, and it was acting as an object store. And so we're doing some processing here, which was tomography reconstruction, where the data is getting spread across all of these different Raspberry Pis. I think each one of these Raspberry Pis is connected to an SSD external drive. The lights make it look amazing. They're just flashing, showing the usage on the disks. And the whole sort of Ceph cluster, this object store cluster, is running across them. And we're processing in parallel using MPI. So it was an amazing project. You can see the results slowly but surely growing as we collect this. And this was some real data that we collected on one of the beamlines at Diamond, basically based off some little 3D shapes we printed to get some interesting patterns so that we could test out our reconstruction mechanism. We 3D printed them in metal. And so this was a really lovely experimental. This was at the prototype stage. So I think a couple of the guys at the scientific computing department did a better job putting this all together to make it look a bit more streamlined. But it was an amazing project. And it was also a project, it was the first one that I'd been involved with the Lego Beamlines. It was very much sort of, I just sat down and got on with that. This one was brilliant because it was a team effort. There were probably, I can't even remember the amount of people at SCD that were involved. There was at least 2 or 3 of us involved from Diamond side. I'm pretty sure there was 5 or 6 people involved from SCD, involved in setting the system up, building the box for it, getting the software running, making everything work. It was a beautiful demo. I think they took it to the International Supercomputing Conference as a really nice demo of Ceph and as a nice tech explainer. So, fantastic use of the Raspberry Pis. And that kind of got us on to thinking, well, what else can we do? What else is generally contained in big, scary computers that we can look at commodity stuff for? And one of the things that I had to work with a lot was the GDA. That's a piece of software that we wrote at Diamond that is for generic data acquisition. And it's what controls a lot of the scientific instruments where we work. And normally where that runs is it runs on a server that's sat in a rack somewhere, and there's usually a few different servers that have got different elements, and then they're usually connected to some motor controllers and some other bits and pieces. And so you end up with this rack of very high-tech equipment, like you can see next to the instruments here, which is pretty impenetrable. And so what we thought was, well, GDA is just a piece of Java software. We can probably get that to run on a Raspberry Pi without too much problem. The Raspberry Pi's got the GPIO pins so that we can maybe control hardware, and it's got the Raspberry Pi camera, so we've got a detector that's just attached to it, and we can probably offload some work to maybe an Arduino to maybe control some other bits and pieces. And so that's essentially what we built. And this is a photo. This is a selfie of the Raspberry Pi sort of beamline that we constructed, which was very much a prototype just to see if we could actually get this all working. And the reason we wanted to do this was actually not for public engagement at all. It was mainly so that if another facility was interested in using our software, we could kind of ship them a Raspberry Pi with everything already installed for them to just play with and see how it worked, rather than having to get them to install stuff and set up hardware themselves. So it was like a nice little cheap way of doing that. But yeah, so this was as I say, a selfie. It was taken by the Raspberry Pi camera. We kind of set up this sort of fake system. So there's a turntable that you can see in the middle of the image. There's a nice white background to give us some contrast. Just off to the right, you can see the Arduino, which is plugged into a whole bunch of things like buttons and some LEDs and the motor controller for the turntable. And yeah, the Raspberry Pi was just in front of where the camera is. And so, yeah, as I say, it wasn't a public engagement thing. You can see it's pretty much taped together with hazard tape. It was very much a prototype, and it was quite interesting. Now, about the same time as this, the great thing about that was, though, that the person who did all this, Ben Seeley, he was able to, he brought in a Lego pirate, as you do, stuck it on the turntable, collected a bunch of images of it, and then we wrote some software to quickly sort of reconstruct that and turn it into a 3D model of this Lego person. And it was really nice, because it was like, okay, that's kind of cool, and it's taking something that we kind of originally built for a very technical purpose, and more as an adventure, sort of as a playing with the system, understanding how things work, and it kind of gave it a bit of a fun element. And as I say, that sort of triggered a few things in my mind, at least, for what we could do with this. The other thing that was happening at the same time was a completely separate project at Diamond called Project M. And Project M was thought up by these guys, and it was very much the idea of the M was for 1,000. And so what they wanted to do was they wanted to have 1,000 samples that they would collect in one day on the Beamline. So the Beamline they were going to use was i11. It's got a big robot arm for doing automatic sample changing, so it can go through and it can quickly do this. But they needed these 1,000 samples. And the idea was that they were going to get students to do this. So they sent the kit, the equipment, to 100 schools. And each of the schools made 10 samples. So these was, I think it was A-level students. They got them to make calcium carbonate, and they got them to pack them into these little tiny glass capillaries and then send them back nicely packed up, so that they would have 1,000 samples. Each of these had a slightly different additive connected to them, so that they were doing real science. That was the interesting thing. The results of this were actually useful results scientifically, and having a big group of people make these made it plausible to do it. And then what was going to happen was that these were just going to get sort of mounted on the Beamline, and it was going to run through and automatically do this. And the idea was to try and go through 1,000 samples in a day. And so one of the great things about working and hearing what's going on with these different projects was we thought, well, hang on, we could do something really cool with this. Can we maybe make this a little bit more interactive? Because none of the students were going to be there on the day that they'd collected the data. There were too many of them that were scattered all over the country. But what we could do is we could kind of broadcast this. And so they did a bit of live broadcasting. But what we also did was we got a few people together to create a Twitter feed specifically for Project M. So this was the Twitter feed we created. And what it did was every single scan, every single experiment that was collected, as soon as the data collection was complete, it plotted the graph, and it took a couple of the images that were collected. So you can see there's one image that was just of the sample itself. So here's the first image, which is of the data that was collected on the Beamline. The second image is of the sample, and they could see the numbers they'd written on it. And the third image was kind of just a random one of the sample being put in. And it was really nice because the person who did the images, because they picked them up at a random time, you sometimes got some really cool sort of flying in as the robot was swooshing around. They put a camera on the end of the robot, or sometimes you got this sort of overview image of the whole system at some point with the robot going and putting it in. But the nice thing was we had all the information, so we could tweet the school, we could basically keep them involved. And I mean, we only got blocked by Twitter once for being a spam bot about halfway through. We managed to get unblocked and then keep on going. But it was a really great project. And I think quite a few people really enjoyed the ability to sort of live see what was going on the Beamline. But it did kind of give us this idea of, well, can we take a lot of the ideas that we've got and can we bring them together into one thing? And so this was the idea of, well, yeah, we've already showed that we can kind of do tomography. Can we create kind of a model tomography Beamline that has the stuff we've learned? So it has the interactivity and the things that we want in it. And so from the software side, we kind of wanted this as a bit of a tech demo as well for maybe careers fairs and things like this to show off the software we used. So we used Node-RED because it was a convenient way to organize things and to connect to Twitter and things like this. But, you know, we used GDA. It was our standard data acquisition system for doing the acquisition and the collection part. And then we used a piece of software called Savu, which was the piece of software that reconstructs our data on the real Beamline. So really, this was exactly the technology stack that we use, apart from Node-RED and Twitter, exactly the technology stack we used at the real facility to do what we were doing, a few slight alterations. In terms of the hardware, because we wanted to make it a bit more interactive, we did go a little bit more over the top. So one of the great things was that we got a lot more people involved, and that meant that we got, for example, the apprentices that were working at Diamond got involved, and they were the people who basically made us the enclosure, machined us this nice aluminium plate, put the holes in the right places, built the backlight and those kinds of systems, and set everything up and mounted it for us. We had the standard system that we had, so the Raspberry Pi camera at the bottom, and the Raspberry Pi just sat there doing the data collection. But because we wanted to potentially look at multiple different samples, we did splash out a little bit and got a small robot arm. These little UART robot arms, they're amazing. We splashed out and got a robot arm to potentially move samples around. And then we connected that to a small sample carousel, which enabled us to, very similar to the sample carousels on the Beamlines, hold a selection of samples so that the sample could be changed completely automatically and remotely. And so what does this look like? Well, of course, we then connected it to Twitter. So the idea was that as a user of the system, you would simply tweet the account, the number of the scan that you wanted to, or the number of the sample that you wanted to scan. And what would happen, sorry, I've gone through these in the wrong order, but what would happen is that the robot arm would, here we go, would go and grab the sample. It would put it on the pin for you to scan. It would then go through and it would collect a series of images, which you can see here, and it would tweet you back the images once it collected them, and then it would reconstruct them. Now we got the center of rotation wrong for this one, which is one of the parameters, but if I go down to one of the ones that's been done previously, there we go, and you can start seeing it's not perfect, but it's completely automated, and it works really nicely from this point of view. So as I say, you mount the sample, and the great thing about this was that it was interactive. We could have it we could take it with us to tech demos. A lot of people at this point had Twitter on phones, so you could get people to interact with it, and it did some quite nice stuff. And I think this worked really nicely at careers fairs and at various things where we were interested in showing people the technology stack, but also not scaring them with the huge amount of tech. Now, the bit that sort of went a bit over the top possibly was the robot arm to do that. That was a little bit complicated, but it was great fun to work with, so I felt that was okay. And so one of the really nice things, if you ever read the Magpie, there is in fact an article on this, the Beamline. So it was Ben Seeley and Emma Ospion, who did the work on this. They were two summer students, and they worked, so each of them did 3 months, sort of 1 year after the other. Ben did the original Lego Beamline, and then we got Emma in to basically to take what he'd already done and turn it into the sort of completed project. And it was really nice. It was an excellent sort of project, and they did a lovely article about it to basically discuss how it was used, which was great. So we've talked a lot about sort of engaging by being shown and engaging by doing things and interacting with stuff, and the interacting element is super important. But actually, there's another element as well, and one of the things that Project M also sort of showed me from the sidelines a little bit was that actually getting people to do the science is really powerful, because it completely changes. Instead of it being a case of you're doing something that is just sort of as a demo so that you can understand how something works, you're actually participating and helping somebody else do science, and the work that you're doing is going to be new and novel, and you're actually helping. And it brings a very different element to it. And so actually this was a point where we started getting involved with another group. And this is kind of less commodity technology, but more just the fact that people are interested in projects, and citizen science was becoming a bigger thing. So this is an amazing project called Zooniverse. If you haven't had a look at it, I would thoroughly recommend having a look at it, because there's a load of very, very fun projects on there. Zooniverse it's a University of Oxford project, so it's based from the physics department in Oxford, and it's in fact Chris Lintott's project. So he presents the Sky at Night, and it originally started as, it was called Galaxy Zoo, and it was all about this idea of how they I think it was Hubble collected so much data that they couldn't process it all, and so they started asking people to sort of the general public to classify what different types of galaxies were. And after a little bit of time, Galaxy Zoo sort of finished, and then they created the Zooniverse, which is all of these different projects, and there's now loads and loads and loads of different ones. Loads of them are really cool. Some of them are about camera traps, so you just get to look at pictures of the Serengeti and stuff and decide whether there's giraffes in it or not. Some of them are things like counting the number of penguins in an image. A lot of the ones that we do are looking more at sort of cell biology and stuff like this, but there's an amazing selection of these different projects, and all of them are very real. All of them are a case of, as a researcher, I don't have time to look through however many 100,000 hours of footage there is of camera traps that we've set up, but as a community we can potentially all look through it and find the bits that are interesting. And so one of our projects is, at the moment, we've got one which is called Placenta Profiles, which is all about picking out particular elements in a cell. So we're looking at mitochondria in cells. So mitochondria are kind of the power plants of cells, and they're what make them work. And we're interested in how that sort of is affected. So are there more or less of them dependent on the disease? And so you get shown a picture, you choose in this case, you click on things that you think are mitochondria, and then you move through. And this is really interesting because alongside this, people are helping us do the science. And in fact, this works really nicely. You can run these on mobile. They're relatively straightforward. You try and make the tasks reasonably easy to do. But you also have all the sections of the about, and you have talk pages, and you have a lot of community that's built around these different projects, which can be really, really powerful and can give you a really sort of good and interesting way of engaging with the public, because they're actually doing things and they're helping the research. So we cannot analyze the amount of data that we have without this help. From my point of view, it's great because what we're doing is we're using the citizens to help us to look at the data we've got and analyze it, and then we use that to train machine learning algorithms to go away and process even more data that we've got. So this is an amazing system. It works really, really well for us. But as a science tool, it's great, but also as a public engagement tool, it's brilliant because it lets people really feel like they're taking part in the project, because they are, and understanding it as well. And actually, one of the things that was really, really good fun was the physics department they have this Christmas lecture every year. So this was in 2020, and it was during the pandemic. And one of the previous universe projects we actually ran as a set of projects in schools. And that was really good fun because the schools basically did part of the project. They learned a little bit about, in this case, it was viruses. They learned a bit about viruses. It was particularly topical at the time. They learned a bit about viruses. They did the project. They got to chat with us as well. It was a really, really good experience. And essentially, it's commodity technology. It's anybody could access this through a phone or through their computer, which was perfect. And they felt, they got really involved. So the final area that I kind of wanted to talk a little bit about was, the other methods as well. And so one of the ones that I'm particularly proud of, it's a little bit different, is kind of engaging by playing. And, people have fun. If people are having fun, then they generally are learning, which is quite good. And so one of the things that we did just before the pandemic, and in fact then modified it during the pandemic, was we created a diamond board game. So this was actually, this kind of was kicked off because of the Project M project. So one of the people on Project M, Claire, and myself, and somebody from Cambridge called Matt, who's a board game designer, got together and we created a board game for Diamond to try to really teach people a little bit about the sort of science we do at Diamond, but also a lot of the stuff about science and engineering when you're working in these areas, like the fact that failure is quite common. I spend pretty much most of my day not managing to achieve the things I want to do because they're difficult and they don't always work out. And then you keep trying and eventually you succeed. But that premise of repeated failure is something you don't often kind of get taught necessarily. And it's sort of that resilience. So we wanted to try and get across this idea of the fact that science fails an awful lot. That's how you learn. There's lots of different types of science, lots of different people who get involved. There's lots of different people who help out. So a lot of the cards are about the people who help behind the scenes to keep everything running. And so we created this as a real game. And that's been distributed to a whole bunch of schools, which is really great. But during the pandemic, we also sort of converted it to a print and play, which mainly involved inverting the colors, because we thought people would be very sad at printing out quite so many high contrast colors on their printers at home. But it's the same game. And I'll post some links later, or if you just do a search for Diamond the Game Print and Play, you can download a copy if you fancy having a game. But the reason I kind of bring it up here is because essentially actually creating this took quite a bit of effort behind the scenes, and getting it technically right was challenging. And I think that's kind of one of the things that I thought was really important was a lot of the things, creating these models, creating these demos, it's hard work. Creating the Lego Beamline took me a lot of weekends of just building and trying things out. Creating the Raspberry Pi systems took probably months of effort in most circumstances, people bringing things together and getting them all working nicely. But they do produce an amazing impact and an amazing sort of tool for people to make use of. So what's next for me? Well, it's interesting because one of the things that I've sort of started seeing recently, so I saw this on the Christmas lectures a few years ago, was the Menace machine, which I think is an amazing concept. So especially working in artificial intelligence, that's a real black box that sort of nobody's aware of. And so the algorithmic stuff I find really interesting, and I absolutely love the Menace concept. So I think it was something like 1961, I think, that this was developed, and it was because they wanted, the person who developed it wanted to show how reinforcement learning worked, but didn't have access to a computer, so they just sort of did it manually. And if you're not aware of this, I would thoroughly recommend having a search around and looking at it. But essentially, it is a purely matchbox-based system that plays tic-tac-toe with you, so noughts and crosses, and it is trained entirely by being played. So essentially, each of the matchboxes contains a series of beads. Those beads are different colors, and you can see the key at the front there, which shows which place. If you pull out a particular bead, it shows you which place the Menace plays at for the game of noughts and crosses. And so you play against Menace, and if it wins, or if it draws, in fact, I think is the case. If it draws or wins, then you double up the number of beads and put them back in the appropriate boxes. If it loses, you take those beads out of the boxes and you don't replace them. And so what slowly but surely happens is that it learns how to play a good game of noughts and crosses. And it's brilliant because it can really clearly explain that actually a lot of the computer algorithms are not doing anything necessarily that sophisticated. Behind the scenes, it's just a case of they're maybe doing a lot of these calculations. They're doing them very, very quickly. But a lot of the premises are quite simple. I really, really enjoyed these. I thought this was an amazing demo that really showed off algorithms, but in a very physical way. And I was inspired by that. And then, looking at some of the work that Matt Parker does, so that's Stand Up Maths, and he's got a YouTube channel. He, as I say, presented the Christmas lectures along with Hannah Fry at that for that particular one. He also did some amazing other physical demos. So I think this is a 4-bit adder. So I think it's something like 4 full adders and a half adder that essentially can add, using dominoes, it can add 2 4-bit numbers together, and I think it almost worked, which was fascinating. It's brilliant. So the sort of the logic gates that you can set up in sort of a glorious way of setting that up. It's amazing if you've got any. As I say, once again, this is well worth looking up if you want to have a browse on YouTube for this kind of thing. And actually, I mean, this was really low tech. This is just dominoes. It's slightly sophisticated way of setting them up, but it's basically dominoes. But also, there are other pieces of technology. So this is one that I've seen a few times. And once again, I really, really enjoyed this. So this is the Moniac. So I think this is kind of described in Terry Pratchett's book, Making Money, as a sort of magical machine. But it exists, and it's a brilliant piece of technology whereby it's essentially, I don't think anybody actually ever used it in reality, but people used it as a training tool. So you pump water in at the top, and that's your income effectively. And then all of these different sort of levers and slides basically just direct the water flow through different things. And the height of the water in each of the different regions shows you how much money there is in that part of the economy at any particular time. So essentially you slide these across, and you can then see what the impact in real time. The money gets down to the bottom, gets pumped back up to the top, And you can kind of see in real time what happens if I raise tax, what happens if I change particular things, what happens if I change interest rates, how does that affect the flow of water through the system. Really amazing project. And so sort of looking at these, it's like there's a lot of very cool things, especially now that I work in AI. It's a case of let's make use of these kinds of models. So I think one of the areas that I'd be really interested in is sort of whether we could create a physical or even just an electronic, something relatively simple that shows what's going on, neural network, or maybe a decision tree that enables the people who are involved, and the participants in the project to tweak the values and to understand how that works. Because especially, in the age of deep learning, where you have potentially billions of parameters, these become very, very black box systems very, very quickly, and they become scary. So being able to sort of break it up and turn it into something much more physical that you can look at and you can go, okay, I understand how this works. And okay, I now see that, yes, the things that are sort of making these decisions are just sort of more complicated versions of this. I think it's a really powerful trope. And of course, there's going to be a version 4 of the Lego Beamline, which I'm actually going to do properly. But essentially, these are the sort of things that are coming up next and the things that I'm interested in. So sort of to sum up, what have I learned? Well, personally, I think public engagement is really critical. I'm pretty much all of the work that I do is funded by the government, which means it's funded by taxpayers. And I think it is so important that I try to explain what I'm doing, what I'm spending people's money on, so that they understand and know and don't think of it as being something that just sort of goes on behind closed doors and it's nice and open. The other thing is, I think using tech for demos is really difficult, but it's absolutely amazing when it works, and it works really, really good. I was going to say the behind the scenes work, though, is just as important as the explainer. And in a lot of these cases, we had multiple people doing behind the scenes work, very, very complicated technical work behind the scenes to make those demos work. And I think that's a really nice way of doing public engagement. If you're not particularly, fond of, standing up and talking to people, you can, do the behind the scenes work, make these things work slickly and well, so that other people can kind of use them to explain and to demo the sorts of techniques and methods that you make use of. Another one I'd say that I really learned was that the inspiration side of things is important. It's really nice to wow people and to show them really cool stuff, but really the long message is the relatability. The best demos that the best times I've given it is, I've been demoing, for example, the Lego Beamline, and you sort of somebody's launching it, and as they walk off, you hear them starting to talk to somebody and say, oh, I'm going to make that when I get home, or I'm going to make something similar, or that looks really cool, I'm going to do that, because then that you've hit them at the point where they can go away and think, yeah, I could do that, I could make this, I could, that I've understood what's going on enough. And ultimately, interactive demos really help. At the very beginning, I showed the original Lego Beamline with the screen, where it didn't have the printout. And making that printout was the biggest thing. Without that printout, I think the Lego Beamline would have never have worked. I never would have made 3 copies of it. It would never have been popular, because it just it just didn't have that impact. And it was that interactive element that really helped. And actually, with all of the other projects, the interactive element on Twitter's, the interactive element on the web pages, it's the interactivity that really, really makes the sort of engaging for people. And so, so I guess my final thing is, engage by tech. It's an amazing way of talking to the public. And if you choose commodity tech, you've got effectively quite a cheap way of doing it, but also one that's incredibly relatable. So thank you all so much for your time. I appreciate it. Hopefully I haven't just bombarded you with information. Hopefully that's been really useful. If you have any questions, please do just ping them in the question and answer section, and I will do my best to answer them. And with that, I will stop sharing this.
Thanks, Mark. That was great, as I knew it would be. So thank you for sharing your enthusiasm for public engagement. I'm sure we have lots of inquiries after the event. I know one of my colleagues on the committee will be in contact with you, I believe. And also, it'd be very interesting to have an update from you in a year or two's time to see how far things have advanced.
No, that would be amazing. I'd really enjoy that. We'll see any new projects that are coming up.
Yeah, absolutely. So we have plenty of time for questions. So if you would like to submit a question, you can use the Zoom Q&A tool to enter something. So don't be shy.
Otherwise, I'll just talk about my motorbike. Nobody wants that.
An alternative, if people don't want to use a Q&A tool, but if you raise your hand via the reactions tool, it's the hand held up vertically, not the waving hand, then I can unmute you. Oh, we do have some questions coming in now.
Okay, so yes, there's a nice one. So my favorite Xenoverse project, I have to admit, so when I first tried Galaxy Zoo, and I was actually really terrible at it. I can't identify different types of galaxies at all. But the one that I really enjoyed, there was an amazing one. I don't know if it's still up actually, called Battling Birds, which was brilliant. So it's just a video feed on a bird feeder. And what the scientists that were involved were really interested in was what the pecking order of different types of birds are. So they basically just kept this bird feeder nicely stocked. And what you had to do was watch the video and then identify what birds were there, but also which was the dominant one. Did any of them knock any of the other birds off to get at the food? So that was a really nice project. But yeah, as I say, yeah, Xenoverse, do have a look. There's so many amazing projects on there, all the way from lots and lots of astronomy ones. If you're into astronomy, there's tons of projects on there for that. Especially with, I imagine there's going to be projects on there with the James Webb Space Telescope really soon. I know that they're going to be very keen to get that kind of stuff up there. But all the way through to, there's quite a few history ones now where people are really interested in old logs, like old ships logs that they're digitizing, and they want people to go through and actually just highlight the bits that they can't read with a machine readable stuff, because it's all handwritten. So there's some amazing stuff on there.
Thanks for that question, Steve. Next question is from Yehia. I hope I pronounced that correctly.
Yeah, so could you combine Arduino with Raspberry Pi to create simple projects for public engagement? Absolutely. And I would thoroughly recommend using the Arduino as well, because we definitely had more than, in the projects we definitely had more than one Raspberry Pi casualty based on somebody inadvertently sticking something a little bit too, and not putting a resistor usually on the GPIO pins and pulling too much current and blowing the circuit. So the nice thing is that you can communicate between a Raspberry Pi and Arduino quite conveniently using the I2C protocol. And then that way you've got sort of a full way of accessing all of the I/O pins, and on the Arduino they're a lot more robust than they are on the Raspberry Pi, so you're much less likely to trash your equipment. But no, as I say, we did that with the first Raspberry Pi Beamline, or the sort of the demo kit. In the end, we didn't for the second one, because we just used a motor controller, and that was reasonably easy to just pin straight into the I/O. But if you want to do something a bit more bespoke than that, definitely agree. And they're pretty cheap. I mean, Arduino Nanos you can get for £5 or so, and I think Raspberry Pi Zero is also pretty cheap. So if you want to make a really low cost demo system, you can probably do something for under £50 reasonably easily with something very cool.
Yeah, there's a lot of scope there, which is within most people's wallets. So I'd hope if they are keen on plugging things into breadboards. Yeah,
no, absolutely. The breadboard becomes the most expensive part, which is kind of insane with a lot of these. I don't know if you still have a Hackspace in Oxford. I know there was one a while back when I think it closed. I don't know if there's a.
I think it might be defunct now.
Yeah, because I know I imagine COVID got rid of quite a few of them, but I always remember that was one of my for doing this kind of project. There was a Hackspace in Reading that I used to go to. I think that's still maybe going, but that was really, really useful because it had a lot of the kit that you might want to use to sort of kick projects off reasonably easily accessible, which was really useful.
Oh yes, I think something which is similar to the Oxford Hackspace is the EOF, which is in the Makespace building in Jericho.
Ah, okay.
So I believe that has lots of tools, logic analyzers, that type of thing.
That's perfect, because sometimes you just really need an oscilloscope, and it's not usually within budgets to purchase one, but a place like that has got stuff like that, which is always good. Yeah, we definitely made use of that quite heavily on several of the projects where it was a case of just being able to wander down to one of the beamlines and steal their oscilloscope for a short period of time to just test something out. It was very, very valuable.
Yeah, sometimes you do need those specialized tools, don't you?
Mm.
But not frequently enough to merit purchasing them.
Yeah, absolutely. Especially the good ones because they're expensive.
So it'd be interesting to consider the remote participation. That is especially useful for outreach, where you can't have students visiting the facility. Can you think of some other areas that might be applicable to?
Yeah, so actually one of the things that I particularly liked, and it was key with sort of Project M, with sending stuff out to people, and with the board game that we've done, we've sent stuff out to people, is that, you know, Diamond is a national facility and the Franklin is a national facility, but obviously it's relatively easy for us to engage with local groups because of the fact that they're close. I can go and visit them, I can drop stuff off, I can just chat with them. But going and visiting other groups, so, you know, hitting people in Scotland, Northern Ireland, require a lot more. You know, it suddenly becomes okay for me to go and give an hour talk to there. It becomes prohibitive, right? Because I don't really want to have to, you know, get a 10-hour train or whatever to get somewhere, or fly just to deliver a short talk and then go. So having those kind of interactive mechanisms, especially where multiple groups can come from various places, does make things a lot better. And actually, in a way, the pandemic has been really useful because it's driven the technologies on amazingly. I think, you know, 5-10 years ago, you certainly wouldn't have been able to have Zoom meetings like this. It just didn't work. And so now it's very, very convenient.
Okay, I see we have another question which has come in.
Does these live projects only completed? Let's see, ROI, like most of the projects done by Diamond, towards more research or commercializing process. Oh, okay. So I think the so actually it's an interesting question because the projects do have a very distinctive lifetime. So the Lego Beamline, for example, it doesn't need a lot of maintenance, but it does need maintenance. You need to keep repairing it. You do need to put a bit of time in. And so they do, if you don't have somebody looking after them, they do die. And that's actually it was a problem a little bit with the Raspberry Pi Beamline. So I think if you go to that Twitter feed, nothing will happen if you tweet it at the moment because it's switched off. It's sat in somebody's office and it's not on and it's not running. And it probably requires a lot of security updates because I'm pretty sure it uses Log4j. So yeah, there are certain projects that have died and they don't come on. In terms of most of the projects done by Diamond more towards research for commercializing purpose. Sorry, I'm struggling a little bit with the question, but I think it's basically sort of saying how do things sort of go? And yeah, a lot of them do sort of die if you don't look after them sort of long term. So you need to have an owner to make them work. In terms of a lot of these ones, so Diamond, I was very lucky because they do have a big public engagement. So sort of remit. So actually a part of what we're supposed to do is public engagement. So I didn't need to worry about the commercialization aspect or whether it was any specific for the science. It was more about the public engagement side. And if we could do the science as well, that was great. Apart from Zooniverse, we really did it for the science first, and the public engagement was an added bonus. So I hope that answers your question. Sorry, I think I didn't do a particularly good job of answering that one.
I wonder if part of the question was about the core science undertaken at Diamond. It's difficult to say from the question.
Yeah. Sorry, so I think so I guess in terms of the core sciences, yeah, I suppose with a lot of the science that we do at Diamond is based on sort of the specific different beamlines have got very specific different sort of niche areas, and it's difficult to find something that works across all of them nicely. So there are some areas where you can, and there are, I guess, the sort of more general things like how the compute works, sort of the MPI tasks, those sorts of things are a bit more general. But a lot of them you have to be kind of specific and work with a particular group on their particular challenge and their particular science. Have you tried setting up demonstrations in museums, e.g. Science Museum? Are there specific challenges in that? So, sorry, yeah. So, David, that's an interesting question. So, the Lego Beamline has been around to a fair number of places. So, I think we exhibited that a few years ago in Oxford, in fact, at the Museum for the History of Science. There was an exhibit there, but that was like a one-day event. And so, yeah, I think a lot of the stuff that we do really requires somebody to be with it, kind of looking after it and making sure it works. The Raspberry Pi Beamline was supposed to be a bit more independent, so it didn't necessarily need someone looking after it all the time, but actually it kind of turns out that it still really needed people. I think my sort of admiration for the people who make museum exhibits has gone up dramatically after trying to make anything that even vaguely does that, because making something that's actually robust and works day in, day out and keeps going is definitely very, very challenging. And possibly something that maybe the commodity stuff is not quite so great for in terms of reliability and robustness. But no, I think, yeah, I think I'd love to do something along those lines and actually put up a permanent display. But I think, yeah, the area we really do focus on is more enabling a person to present the science that they're interested in and give them the tools to help them explain that. So usually it's kind of like a I don't know, a facilitated demo of something, if that makes sense. So yeah, exhibitions, things like the Big Bang Fair, there's a couple of big events that happen, big science events that happen around the country, and Cheltenham Science Festival, Blue Dot Festival, things like this. Those are the kinds of places that we do most of the work, I guess.
We still have plenty of time for questions. Here's another one. Another from my colleague, Steve Crovers.
Yeah, so encouraging students for a career in science is a really interesting one. So I think that's definitely one of the areas that I've kind of focused on, and it's because I do see it as an area that we find it difficult to recruit in. It is difficult to recruit people as software developers. There's not, it's a challenging role, it's a difficult role, it's a technical role, and that kind of, there's definitely less people than are needed to do all of the roles that we have, and so picking up people is challenging. And so I'm always really keen, especially from kind of a diversity point of view, the more people who get involved, especially if you can try and encourage people from underrepresented groups to get involved and get engaged, that sort of is for me, I guess I'm just trying to help future Mark out. So in 5 years time or so, when I'm trying to recruit new people, there's a chance there's a few more of them. I guess that's the key thing. But I'd say a lot of the time people don't realize how broad science is. And I think especially at school, a lot of you've got science, you've got maths, you've got technology. They are very, very different subjects. And so I've done quite a lot of school engagement projects where, there's a really great thing that some of the groups do called, it's kind of what's my line. And the idea is you go in and it's kind of, you get like 4 or 5 students and they have 3 or 4 minutes to guess what your job title is, and you bring some clues along with you. You bring some items that they can ask you questions about, and they can ask you any question they like to try and guess your job title, and then you give them a score at the end and they work their way around. So you see loads of kids by the end of it. And one of the things that always surprises me is when they ask, so what they often ask is they say, okay, so which bit of STEM do you do? So which bit of STEM? And it's like, well, I do all of STEM because I work across, because naturally my job involves all of these different elements. A little bit of it is engineering, a little bit of science, definitely involves maths underpinning it all, and the technology is what I use on a day-to-day basis. And they're like, but which bit do you work on? And it's really interesting that they don't see that all of these things are together. And I think once people realize that they are a bit more of a continuum, and that there's a load of jobs that they probably hadn't considered are kind of STEM careers, so there's all sorts of things like surgeons and doctors that realistically you need the high levels of skills in science and understanding that. There's all kinds of software roles that run behind the scenes in all of these other places to bring that. And I think when people start realizing that, they do become a little bit more engaged, and you do see a slight uptake. We definitely saw that with the board game when we did studies looking at that. whereby just exposing people to the idea of all these different careers, they kind of went, oh yeah, maybe I would want to be a scientist then, because it looks, you're, you know, an engineer, because there's some interesting elements in there, some interesting things that they can do. But we'll see. We'll see if my job is any easier in 5-10 years time recruiting new people.
Oh, by the way, thanks for showing the Isle of Jasmine,
Oh yes.
the data center, because my colleague, Jonathan Churchill, gave a wonderful talk on that about 2.5 years ago. And we were trying to arrange a tour of a data center in 2020, but some events intervened. And I do hope we can arrange such a tour later this year.
No, I mean, it's, I think that's the thing. They're beautiful, beautiful. Yeah, I haven't been to the ground floor of R89 has got some amazing, because I think that it's in R89, isn't it, Jasmine?
Yeah.
Yeah. So it's got some amazing kit in there. I haven't had the opportunity to go there for a very long time. That's a real shame.
So I'm thinking that possibly we've run out of live questions, but people do have your email address, I hope.
Yeah, absolutely. Or contact me on Twitter. That's the easy way to get my attention.
Excellent. Thanks very much, Mark. Thanks again.
You're welcome.
So if none of my other committee members have anything to contribute, I'd like to remind people we'll be having our first hybrid event on the 14th of April, where we'll be looking at big data computing in healthcare. Get there early for refreshments starting from 7 o'clock. So to wrap up, just like to thank you again, Mark, and we look forward to getting an update from you in a year or two's time. Thanks very much. Goodbye, everyone. Oh, the last thing is we're making a recording of this, so it will be available in due course.
Thanks, everyone.